In this video, we're going to look at properties of the definite integral. 5 properties. The first 2 are both related. They're both called linearity of the definite integral. And that means that if you have a definite integral of a sum or difference of 2 functions, that can be split into a sum or difference of the two definite integrals, where the limits of integration are the same. They're all from a to b. Also, if you have a constant times a function for your integrand, you can pull that constant k out to the front of the integral. Okay, so for an example, suppose that the integral from 2 to 5 of f of x dx is 3, and also suppose that the integral from 2 to 5 of g of x dx equals negative 7. Then the integral from 2 to 5 of f of x plus 5 times g of x is equal to what? Let's see. So let's rewrite the function or the integral over here that we're trying to find. It's the integral from 2 to 5 of f of x plus 5 times g of x. That's all in the integrand right there. Dx, that indicates end of the integral there. Okay, well, by this second rule right here, we can split it into 2 integrals, the integral of f plus or minus the integral of 5 times g. Okay, so we can split that into the integral from 2 to 5 of f of x dx plus or minus the integral from 2 to 5 of 5 times g of x. But we can also pull that 5 out front by this rule. So let's go ahead and do that. Pull the 5 out. So it's 5 times the integral from 2 to 5 of g of x dx. Now we are given that the integral from 2 to 5 of f of x is 3, and that the integral from 2 to 5 of g of x is negative 7. So then we can plug those in here. We'll have 3 plus 5 times negative 7. So negative 35 plus 3 is negative 32. And we didn't even know the functions f or g. All we knew was 2 of the integrals, but we could use these properties to find that integral. The next 2 properties have to do with limits of integration. So the first one says that the limits of integration, if they're a and a, so if you're not really integrating over any x values here, you're just taking the integral from little a to little a, you cover nothing, your x value doesn't move, so that integral equals 0. And the integral from a to b of f of x can be rewritten. It's the negative of the integral from b to a. And this can be explained through the rectangle definition of a definite integral and going backwards, and it has to do with this dx out here. But it's a little bit easier to just accept for fact at this point. So using these 2 properties, suppose that the integral from 0 to 5 of f of x is 6. Find the integral from 5 to 0 of 3 times f of x. Okay, well, we want to find, let's see, the integral from 5 to 0 of 3 times f of x dx. Well, we can use that constant rule from up here, right here, and pull the 3 out to get 3 times the integral from 5 to 0. But this is backwards. Typically, the lower limit of integration is smaller than the upper limit. Okay, so we can reverse it here because the integral from, if we flip it, the integral from 0 to 5 then is the negative of the integral from 5 to 0. Okay, so this equals the negative of the integral from 0 to 5 of f of x dx. And the parenthesis there indicates multiplication, so it's not 3 minus the integral, it's 3 times the negative of the integral. So that gives us 3 times the negative of, let's see, that integral is 6. Or negative 18 in this case. All right, and the last property has to do with adjacent intervals. So, the integral from a to b of f of x can be rewritten, okay, or split into 2 different integrals, where, if you look at this, c is in between a and b. So, the integral from a to b of f of x can be split into the integral from a to c plus the integral from c to b. And this is kind of easier to imagine on a little x-axis here where we have a, c is somewhere in between, and there's b. So the integral from a all the way to b, that's this integral, is equal to the integral from a to c, so it's equal to that part, plus the integral from c to b, so plus that part. Okay. All right, so suppose the integral from 0 to 5 of f of x equals 6, and the integral from 0 to 7 of f of x is negative 11. How could we find the integral from 5 to 7? Well, let's just draw a little number line here. So here's 0, 5, and 7. So we know the integral from 0 to 5 of f of x equals 6, and the integral from 0 to 7 of f of x is negative 11. We know that the integral from 0 to 5 plus the integral from 5 to 7 equals the integral from 0 to 7 by this property. Okay, so let's write that out. So we know that the integral from 0 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx equals the integral from, let's see, all the way from 0 to 7 of f of x dx. And we know the integral from 0 to 5 is 6. So this whole first part becomes 6. And the integral from 0 to 7 is negative 11. So we have 6 plus this whole integral equals negative 11. Well, let's subtract 6 from both sides, and then we'll get that the integral from 5 to 7, right here, that's supposed to be a 7 at the top, of f of x dx equals this negative 11 minus this whole integral minus 6, or negative 17.